Okay, this is the third lecture in the discrete event um, items from the PowerPoint number 2. We'll back up a little bit. What do you do if you want to preempt a scheduled event? So this is required in 15.1. And first of all, you need to have a place where you store the entry pointer for the scheduled event, and you can call it anything you want. Here we use PE hold, which is a type entry pointer, and we include this definition before any of our user code. So this declaration is outside all of the code that we write. So whenever we schedule an event, in the case of 15.1, you want to pay attention to end of service events. We hold or store the entry pointer for the scheduled event in PE hold simply by equating it to the result of the schedule function. If you want to get its attributes, then you have to go through sfn entry to convert the entry pointer to an entity pointer, or actually get the entity pointer. And then also you'll want to be able to do things like save the remaining time in the event. So here we in the event calendar, any entity that's stored there has a special set of attributes, and one of those attributes is the end time for the event, or the time at which the event is to occur. And we use function enttime, and the argument is an entity pointer for that particular event entry. So you go through this first using PE hold to get the entity pointer, and you use the entity pointer in this function that returns the remaining time, or the time at which the, I'm sorry, not the remaining time, the time at which the event is scheduled to occur. We subtract t now from that, and that gives you the remaining time. And then you may want to save that information in another variable. Okay, we'll advance to the next slide as soon as, okay, here we go. So this continues how to preempt a schedule event. To remove it from the event calendar, we use the su file remove function, and nclnr is a sim file pointer which points to the event calendar. It's a special reserved variable in Awesome. We also send it the entity pointer, or excuse me, entry pointer that's stored in the event calendar. Then we want to store the remaining time in an attribute, so we calculated that on the previous slide. We can send that using PE stop, which is the entity pointer and the attribute to value, and store that. And then we can put this interrupted item that we've removed from the event calendar into another file, and store that, say, in file 3. Okay. Note that we can remove the item from the calendar if we've saved the entity pointer information. Okay, so PE hold is an entry pointer for the event calendar item. PE stop is the entity pointer. Removing PE hold just removes that linkage from the file, but we still have the attribute information in PE stop. Here's a quick function on searching a file for an entry value. We have an entry pointer in next, an entity pointer in int, and in a for loop we have the initial condition is next equals mmfe of 4, which means the first entry in file 4, and we execute the code in this for statement until next is null, which means we've reached the end of the file, or we find what we're looking for and we break out of the for statement. So the first statement is to get the entity pointer. So we have the entry pointer in next, and we convert it using this function, and we find the entity pointer. And then we test ltrib5 using that entity pointer against the value of 7. If it if the entity that we're looking at has an LTRIB5 value of 7, we break out of this loop. Otherwise, we look at the successor of next and set that to next. So we look at the next entry in the file, go back to the top of the loop, and execute it again. Some tricks. This is in particular for 15.1. If you want to collect statistics on the busy percentage of the server, you can set up a global variable, say XX1, where it is 0 when idle and 1 when busy. And then we collect something called timestat statistics by defining a timestat statement in the control model. We select XX1 as the variable we're going to collect statistics on. Timestat statistics are similar to collect statistics. You have to number them from 1 to the total number of timestat statistics you have. And then Awesome takes care of monitoring XX1 and collecting statistics as it may change. In your code, you want to change values from 0 to 1, where 0 represents idle, 1 represents busy. You can see examples of that in the bank teller problem. If I do that, then the average of XX1 that's reported in the timestat statistic gives us the time integrated average or percentage of busy time for the resource. Time in the system, same as in the network models really. You set up attrib1 as tnow in the arrival event, define a collect statistic in intlc using this function. Su collect new defines a new collect. This is the collect number, a label, and information about the histogram, similar to what we do with the collect node. And then you collect statistics using tnow minus attribute 1 in the end of service event. So you call collect to collect those statistics, calculate the difference between now and attribute 1, which is the time of the system, give it the collect number, and you're all set. Time in the queue statistics, we need to set up another collect variable in intlc. So you do that again with collect new. You need to set up an attribute of the entity to store the time when you file the item in a queue. So just before you call that file function, you want to set attribute 1 and equal to tnow. And so we do that in the code in this function. Then we calculate and collect statistics when we remove the item from the file. So after we remove an item, say in the end of service event to process the next customer, we store the entity that's removed. This is the entity pointer. And then we collect statistics on the difference between tnow and attribute 1 of that entity pointer and file it in the appropriate collect number. Base problem, here's some hints. Use one file for the queue and rank all on an LTRIB values, which is the priority or type number. You can define the file using the priority statement in the control model. We did it in the basic example using the function to define a new file, but you can also define a file with the priority statement just by identifying the file number and how the file is ranked. So instead of FIFO, we're going to rank it on low value first in LTRIB1, and LTRIB1 would be a low number would indicate a high priority, and a higher number would indicate a low priority. So priority 1 would be the highest, and the items filed away in that file would be ranked accordingly. On the embellishment, my suggestion is to use 3 files for the entities waiting for service. File 1 would be type 1 or high priority items. File 2 would be low priority preempted items, and file 3 would be non-preempted items. Then all you have to do in your code when you're processing items at the end of service, process everything in file 1 first, and if file 1 is empty, go to file 2, and if file 2 is empty, go to file 3. So you can use this kind of with an if-else construct, and NNQ of file 1 would be 0 when it's empty. Same for file 2 and same for file 3. So that's one way to handle it. You can also do it in a single file if you set up the priorities properly. Again, keep a global pointer to the entry in progress in the event calendar. Use a global variable XX1 for the status of the server and collect time stat statistics. These are time integrated averages. In other words, the observations that are collected in time stat are weighted by the amount of time the variable has had a particular value. So here's what a time stat statistic looks like. You can find this in the control model editor. Okay, that's it for the video lectures on the second discrete event PowerPoint, and I hope you find these useful, and please give me some feedback on all of these. Thank you.